Okay, so today's video is the fourth video in our unit on stoichiometry. And you can see by the title, it's called Putting It All Together. And it's basically using all of the conversion factors that we learned in chapter 10 with the stoichiometry concepts that we have learned in this chapter. So this is, any problem can start with grams, right? It could start with atoms or molecules. It could start with moles. It could start with liters of a gas at STP. And what we did last time, liters of a solid or liquid, and we would use density. So the first thing that we really need to understand is no matter what is given to us, so any of what is known, what is given to us in the problem, the first thing that we're going to try and do is convert it to moles. So if it is given to us in terms of particles, so that would mean if you are given something with a number of atoms, molecules, or formula units, what you're going to use for that's Avogadro's number, right? That's going to be 6.022 times 10 to the 23rd. That's the number of atoms, molecules, or formula units that's in 1 mole. If you're given liters of a gas at STP, right, you're going to use 22.414 liters of gas is equal to 1 mole. We know that if you're given the given information, the known information in grams, you're going to use the molar mass. And what we learned last time, if you're given the volume of a liquid or solid, you need to use the density to convert to grams and then use the molar mass in order to convert to moles. So you're basically using all of these conversion factors, right? And using the density in order to convert to moles of what's given. Then we know in order to go from moles to moles, this is where you use balanced chemical equation. That's what BCE stands for. You're going to use the coefficients from the balanced chemical equation. And then just the same other way, that if then the question asks for, right, your unknown is what the question is asking. So if it says how many atoms, you're going to use, again, Avogadro's number, 6.022 times 10 to the 23rd. If it says how many grams, you use the molar mass, right? If it says how many liters at STP, that's when you use 22.414. And if it says how many liters or milliliters or cubic centimeters and the compound or element is a liquid or solid, then you're going to need to use the density. So, you can go back and refer to this diagram and think of where am I starting and where am I ending? And each one of these arrows in this diagram is going to be a parenthesis. So if we look at the first one, here's the balanced chemical equation. Right? If we were in class, I would say, what type of chemical reaction is this? So look at it. Do you know what type it is? It's a combustion reaction because we're reacting with oxygen. We're making carbon dioxide and water. And I'm giving you the density of the water because the water in there is a liquid. So the question says, how many liters of oxygen gas at STP are needed to produce 46.99 grams of water? So circle the do, liters of oxygen gas. This is what's given to me, 46.99 grams of water. So I always take the clue and I write it out front, 46.99 grams of water. If you look at the map above, where am I starting this problem? Right? I'm starting this problem right here, grams of something that's been given. So the first parenthesis, I use the molar mass to convert to moles. Remember, where am I always going? I'm trying to convert to moles of known. So 1 mole of water, and the molar mass of water is 18.016 grams. Then, where do I go next? I go to moles, or I have gone from grams to moles. Now I'm doing this leap. I'm going to moles of the unknown. And what do I use for that? The coefficients from the balanced chemical equation, right? The question is asking me about water and oxygen, right? So match up my units diagonally. So 6 moles of water goes on the bottom here so they can cross out. And there's 15 moles of oxygen, right? 15 moles of oxygen will need to be consumed to make 6 moles of water. And then where am I going now? The question says liters of oxygen gas. So I'm going here, liters of a gas at STP. And what do I use for that? 22.414. So 1 mole of oxygen gas is 22.414 liters. Remember, that's only true if it says at STP, which it does. And now if I look at this problem, right, grams of water cancels out with grams of water, moles of water to moles of water, moles of oxygen to moles of oxygen. I plug this in my calculator, 46.99 divided by 18.016. I can skip the times 1 because I know in my calculator that's meaningless. Then I would do times 15 divided by 6 times 22.414. My answer comes out to be 1462 liters of oxygen gas at STP. And before I move on, I just want to check and make sure I have the right number of significant figures. This number has 4. Any number that comes off the periodic table kind of carries with it 4, and 22.414 has 5. So yeah, this guy having 4 significant figures looks good to me. Okay, so we're going to continue on onto page 9, and we're going to do the 3 problems on page 9. So number 10, if 100.0 grams of C6H6 are reacted, so this is my clue, how many milliliters of water are produced, right? Milliliters of water, that's volume of a liquid. That means I'm going to use density. So I start these problems out all the same. I take the number that's given to me and I write it out front, C6H6. Right? If you go back to the map on the previous page, or you can look at it on your notes packet, if we start with grams, the first thing we do is we convert to moles, right? 1 mole of C6H6 grams, so this has to be the molar mass, 78.108 grams of C6H6. Now, since I have moles of known, I need to convert to moles of unknown. Unknown is what the question is asking about. This is where I use the coefficients from the balanced chemical equation. So 2 moles of water. Oops, it's not water. I was looking ahead. It is, in fact, 2 moles of C6H6 will react to produce 6 moles of water. And then the question wants us to do milliliters of water. And this is where a lot of students go wrong. I'm just going to scroll back up to this diagram here, right? Think of where we started in this problem. We started with grams. I converted to moles of C6H6. Now I converted to moles of water. Where do I want to go to? Volume of water. So what do I need to go to first? Grams. So I'm going to have actually 2 more parentheses in this. Converting from moles of water, remember moles goes on the bottom, 18.016 grams on the top. That's the molar mass of water. And then I take that density of water. On the previous page, it said the density of water was 0.99705 grams per milliliter. Remember, that can get broken up. 0.99705 grams equals 1 milliliter. 0.99705 grams goes on the bottom and 1 milliliter goes on the top, right? Some of the things that we're using to help us out with these problems is what we're converting to goes on top. So I want to convert 2 milliliters. Milliliters is going to need to go on top. Do my units cancel out? Moles of water, grams of water, grams of water. Looks like they do. I plug this all into my calculator. 4 significant figures. All my molar masses have 4 significant figures. The density is 5 significant figures. So my answer can have 4 significant figures, and I get 69.40 milliliters of water. Okay, the next problem here, number 11. Let's take a look at, the circle the do and underline the clue. I'll keep that up so we can reference it. 4.6 times 10 to the positive 26 molecules of carbon dioxide are produced. How many liters of oxygen gas at STP were reacted? So I'm doing these problems exactly the same way. 4.6 times 10 to the positive 26 molecules of CO2. I take the clue that's given to me and I put it out front, and then I always convert to moles. 1 mole of carbon dioxide is going to be equal to 6.022 times 10 to the 23rd molecules of carbon dioxide, right? Avogadro's number. Now I have moles of known, which is carbon dioxide. I want to convert it to moles of unknown, which is oxygen gas, and that's where I use the coefficients from the balanced chemical equation. So the balanced chemical equation says for every 12 moles of carbon dioxide, I will need to react 15 moles of oxygen gas. Right? Remember, the only time we are using those coefficients from the balanced chemical equation are in a parenthesis that is mole over mole, when we make that leap in the middle from moles of known to moles of unknown. Oops, I didn't really need to put an equal sign there because I didn't finish the question. The question says how many liters of oxygen gas were reacted. If I stopped right there, I would end with moles of oxygen gas, but of course I want to go to liters. So 1 mole of oxygen gas is equal to 22.414 liters of oxygen gas at STP, right? It says STP right in the problem. So this is what I'm plugging into my calculator, right? Checking to see, did my units cancel out? Molecules of carbon dioxide cancels out with molecules of carbon dioxide. Moles of oxygen cancels out with moles of oxygen. There we go. Moles of oxygen, moles of oxygen. So what unit is left? Liters of oxygen. That's what I want. My calculator gives me 21,401. But this guy over here, the 4.6 molecules, 4.6 times 10 to the positive 26 molecules only has 2. So it sort of doesn't matter that these guys have, the 6.022 has 4, and this guy has 5. My answer should only have 2, so actually just 21,000 liters of oxygen gas at STP. And then number 12, how many molecules of C6H6 were reacted to produce 64.9 liters of carbon dioxide at STP. Okay, so 64.9 liters of carbon dioxide at STP. You can write it, or it's okay if you don't, right? Every single problem, the first thing I do is convert to moles. So let's keep unsyncing here. 1 mole of carbon dioxide will have the volume of 22.414 liters. Now I go to the coefficients from the balanced chemical equation, right? I want to know about molecules of C6H6. The coefficients tell me that 2 moles of C6H6 will react, and they will produce 12 moles of CO2. And then the question asks, now that we have moles of C6H6, it wants to know how many molecules that will be, right? Well, 1 mole of C6H6 will be 6.022, Avogadro's number, times 10 to the 23rd molecules of C6H6. Plug this into my calculator, right? Multiply by the top, divide by the bottom. Check to make sure that my units cancel out, which they all do except for molecules of C6H6, which is what I want. check sig figs. That number has 3. 22.414 has 5. 6.022 has 4. Remember, these guys don't matter in the middle because we didn't measure that. Those are whole number ratios. You can't have 2.5 molecules, so those are whole numbers. So my answer comes out to be 2.91 times 10 to the positive 23rd molecules of C6H6. Okay, so that is what, those are the problems that that you're going to be working on your, or I should say for your homework tonight. So your homework tonight is going to be basically all of those problems between basically the gram to gram and the density ones. The numbers for them, I think, are going to be 11 through, let me check. It is, in fact, 11 through 14. So it's actually 11, 12, 13, 14. There's only 4 of them. So tonight you're doing, oh, it clunked out again. Tonight you're doing 11 through 14. There we go, 11 through 14. So after this, you should have completed all the way up to 16 because that was the homework for last time, was numbers 15 and 16. Okay, so the big, to wrap it up here, we are always, referring back to this chart right here and thinking about where am I starting and where am I ending, and really looking at the map of where do I need to start, where do I need to go, and using all of those conversion factors in order to do that. So do those problems, the 11 through 14. The answers will be posted on Schoology. Check your work, and then we will go over this next time we meet. Okay, so this will be what we go over on next Monday. So Monday the 20th. Okay, have a good week.